Wait for the wind to stop. Hi guys, my name's Jo and I'm an experience officer here at Science Space in Wollongong. We got another email, this time from the Shellharbour Space Eagles, a team of kids who are competing in this year's first LEGO League. I'm not gonna lie, I was a little bit disappointed that you guys aren't actual Space Eagles, but I'm gonna let that slide for now. They're working on a couple of really cool things, which I can't talk about, but they had a specific question. They wanted to know whether or not it was possible to create a vacuum in space, and I may have some ideas about that. First, we need to take a look at the atmosphere. I mean, not look at the atmosphere, it's not actually, you know what I mean. Okay. The air around us is made of stuff. Billions and billions of tiny molecules of gas. These gases may be too small to see, but they're there, and like everything that exists, they have mass. They have so much mass, in fact, that if you took the column of air above this 5 cent piece and condensed it all into something that you could hold in your hand, you would have something that weighed about as much as this 2-litre carton of milk. So why doesn't it feel like I'm buried under a bunch of milk cartons? Well, it's because all of the air pressure inside of me is roughly the same as all of the stuff on the outside, so they cancel each other out. Plus, our bodies are sort of elastic enough to deal with the mass of all of the molecules of air above me in Earth's gravity. It's when we start to get differences in pressure that things really get interesting. Like if I took away all of the molecules of air inside a thing to make a vacuum. Gases always want to take the shape of their container. Take this balloon. I can fill it up to a certain point before it starts to expand. Then I have to start forcing air into it to make it bigger. There's a bunch of molecules pushing against the sides. It doesn't keep expanding unless I push air into it because of the atmosphere around it pushing back. But if we start to take the air away, there's not as much pressure or weight on the outside to stop the balloon expanding. We can test this out using an actual vacuum chamber. Here's the balloon I blew up earlier. If I stick it in under the dome and pump out all of the air, then we can see it starts to expand. So every day on Earth, there are a bunch of molecules pressing down on us. And if we take those away, we create a vacuum. And this is where we get back to the original question. I mean, we know how to create vacuums on Earth, but can we do the same thing in space? And the answer to that is, well, yeah, kinda. You see, space itself is a vacuum. As you head further and further up into the sky, there are fewer and fewer molecules of air, so the pressure starts getting lower and lower until there's nothing there at all. It's why astronauts have to wear massive suits when they're floating out there in the nothingness. They need to have something to stop all the air rushing out of their lungs. So I mean, technically, since all of space is a vacuum, you don't really need to create one, unless you wanted to take something like this up into the International Space Station and put a vacuum inside of a spaceship inside of a vacuum. And then maybe you could get an even smaller vacuum chamber and put that inside this vacuum chamber, and then you'd have a vacuum inside of a vacuum inside of a spaceship inside of a vacuum. And then you could even take another even smaller one and put it inside, and then you'd have a vacuum inside of a vacuum inside of a vacuum inside of a spaceship inside of a vacuum. And hang on, what was I talking about? Thank you so much for your question, Shellharbour Space Eagles. Make sure you let us know exactly how you go. Good luck with all of the competition. And guys, if you have any more questions or anything else you'd like us to investigate, please leave your comments down below and we'll see what we can do. Thanks so much for watching, guys, and I'll see you all in the next one. Bye!